Here's my project for tutorial 8. It involves 3 photoresistors and 3 LEDs, and the photoresistors determine how bright the LEDs shine by how much light they receive. So if you take a flashlight and you shine it on a photoresistor, the corresponding LED will light up, and you can see as I get close to the other one, it gets brighter, and then as I go far from the other one, it gets dimmer. So the less light that's on it, so I guess it's hard to see on the camera, but the less light that's on a photoresistor, the dimmer the LED will be. The components I used in this video are the Arduino Mega Board, 3 photoresistors, 3 red LEDs, 3 100 ohm resistors, 3 10,000 ohm resistors, and the various jumper wires used to connect it all. Now I'll go a little bit more in depth into how the circuit works. So starting off with the board, you'll see here that there is a red and black cable coming out. And this brings 3.3 volts of electricity into this strip here on the big breadboard. And the black cable grounds it from this blue strip here back to the board. Then from this strip, you'll see along this cable, and this cable, it brings the electricity from this strip into each of these 3 mini breadboards. Now on these mini breadboards, that current goes through the photoresistor, and then through this 10,000 ohm resistor, and comes to the ground back into the big breadboard. Now this blue cable here, which is found in all of the 3 of the mini breadboards, comes from inside this little series circuit and brings an analog input value from the photoresistor into the board where it'll be used with a code. And the LEDs also use the same ground strip as the photoresistors, but they get their power from the board from digital output pins, which is these yellow cables. And so these digital outputs will give power when the code tells them to, through this 100 ohm resistor into the LED, which goes back into the ground strip. That repeats for all 3 of these series circuits for the LEDs. Now you can see the schematic of the picture alongside an illustration of it, both made on Tinkercad. Starting off with the photoresistors, as you can see in the video, you have the 3.3 volts of power coming from this strip here, through here, wired in series to the photoresistor, through the 10,000 ohm resistor back to this ground strip, which are both wired into the Arduino board. And how these photoresistors work is they detect how much light they are receiving and applying resistance onto the voltage based on how much light. And then this blue cable here comes into analog input and gives an analog value to the board corresponding to how much light the photoresistor receives. Now over here on the schematic, you can see here's 3.3 volts, and this is the power strip on the breadboard, and here it's coming into the photoresistor, and then here through the resistor and into the ground, and then this wire branching off is the analog. And it's a little messy, but you can kind of see how it repeats here and here. Now moving on to the LEDs. The LEDs are each wired also in series with not constant power coming in, but from the digital outputs. So when the code tells it to, it will send voltage through this cable, through the 100 ohm resistor just to protect the LED, into the anode, and then out through the cathode into the ground strip, which is then wired back into the board up here, and that repeats for each of these LEDs also. Now you can see over on the schematic, there's an LED here. Here's the power coming, or the digital output coming from the board through the resistor, through the LED, and into the ground. And again, it's kind of messy, but you can see how there's another one coming from here through the resistor, and then in through here into the LED, and out into the ground, and the same for the other one as well. Alright, now you can see the code for my project. To start off, I'm creating 3 variables here called LED1, LED2, and LED3. So the reason I'm defining them here before the setup loop or the main loop is because I want to make them global variables, meaning they can be used anywhere in the code. And the reason I'm doing this is because I need to use them later on, but I need to define them inside of a loop. So to use them inside of a loop, it'll be out of scope if you make them not a global variable. So I need to make them global variables so they can be used inside a smaller loop. Then down here in the setup loop, I'm just defining the digital output pins I'll be using as output. And then I'm defining the serial monitor to be used at 9,600 refreshes per second. Then down here in the main loop, which will run repeatedly, I'm creating 3 variables called photo1, photo2, and photo3, which are basically just the readings of the photoresistor. I'm creating variables to make them easier to work with instead of having to type out analog read every time. And here I'm just printing to the serial monitor the values of these to help with debugging and whatnot. Now here are the loops I was talking about earlier in which I'm changing the values of LEDs 1, 2, and 3 because they're going to be the values which are used to illuminate the LED and determine how bright the LED should be. So first I have if the value of photo 1, or if you go back up here, the reading from analog pin 0 or the photoresistor, if it's less than 400, set LED 1 to 0. Basically keep the LED off. A value of 0 will keep it turned off. I measured the ambient light in the room and it stays under 400. So this is so the LED won't turn on without the flashlight on it. And then here, if else, which means that if it's greater than 400, I guess greater than or equal to 400, to set LED 1 to a mapping of photo 1 on a scale of 400 to 700 mapped onto 0 to 255. So 0 to 255 is the range that the LEDs can be illuminated, with 0 being off and 255 being full brightness. And 400 and 700 is the range that the flashlight will change the LED. I measured that using the serial monitor printouts. So 400 is just the minimum of the flashlight being shined on them, and 700 is the max. So if it's at around like 690 or so, a little under 700. So if it's at 700, it will be at full brightness, and if it's at 400, it'll be the minimum. So if it's a little bit above 400, meaning the flashlight's on a little bit, it'll be a little bit bright, and more and more and more until it's at 700 of the full brightness. Then that same loop is repeated twice, but with the second and third photoresistors and the second and third LEDs. Now here, I'm just telling the code to illuminate the LEDs to that LED value. So it'll send whatever value between 0 and 255 is determined for the first LED. It'll send through digital output 13, and same for LED 2 and 8, and LED 3 and port 2. And then down here, I'm just printing those values to the serial monitor. Now you'll be able to see how the values of the different variables in the code change along with the code and the project as the flashlights shine. So if I hold the flashlight onto this light, you can see how the values for photo 3 and LED 3 increase because the light is shined on the photoresistor, so it returns a higher value, and the LED changes a higher value based on that. And as I move farther, you can see it gets smaller, and LED 2 and photo 2 get bigger. And then same as when I go to photo 1 and LED 1. So as the light changes on the different photoresistors, the variables change, and the corresponding LED variables change as well.